Hello. Okay, here we go. Okay, so definition of a parabola. A set of all points equidistant from the vertex, or I'm sorry, the focus and the directrix. So what we need to do now is we need to talk about what the focus and the directrix are. Right, so after you get that down, we'll flip to a new page. Ready? Okay, flip to the second to the last page. See all the notes here? You, come test time, can either use the notes that I provided for you, basically this last sheet, you would tear it off, or you can put together your own notes. And I'll show you what some people have done for theirs. But I'm done trying to put notes together for this section for people because there's always a complaint, so people can do it themselves. So that's how I roll. So as you look at a parabola, this is a parabola right here, and you guys are used to seeing this portion of the parabola along with the vertex on the bottom. But what we have is inside a parabola, you have this focus point right kind of in the middle. And it happens to be p units away from the center. And then you have this line on the outside. It's called the directrix. And that happens to be p units from the center as well. Sing well. Godspeed. So when we look at the definition, it's not very interesting, but it's the way that we prove the formula. So I'm only giving, you don't have to ever memorize this. I'm just telling you so you understand where it comes from. If we were to locate a point on that parabola, that point would be whatever distance it is from the focus would be the same distance it is from the directrix. Now, that may not look like they're the same because the graph probably isn't drawn quite right, but that's the definition, okay? These would be the same distance, and that's how you generate the points. That's it. Okay? So that's where you get focus and directrix from. Everybody good? Okay. Back to the beginning. You have two different parabolas, ones that are vertical and ones that are horizontal. If they're vertical, they have this form, y equals a times x squared. If they're horizontal, it's x equals a times y squared. What's the difference in the equations? X and the y. In one situation, x is squared, and the other one, y is squared. Some people say, well, x is on the right or it's on the left. Well, that really doesn't matter at all because then I can write it like this, and all of a sudden, you know, it's what's being squared. So I'm going to draw these graphs. Oh, nice and organized. We've got spaces for graphs and everything. Oh, thank you, Mr. Gantz. You really care about our learning. Yes, I do. Your learning is precious to me. My precious. Love that movie. Watch Lord of the Rings for days on end. Is the first parabola a function? Yes. Is the second parabola a function? No, it does not pass the vertical line test. It's not a function. But we can still figure out how to graph them. Now, The axis of symmetry divides the parabola in half. What kind of line divides this first parabola in half? Vertical or horizontal? Vertical. Vertical line divides this in half. What kind of equation is that? X equals or Y equals? X equals, and it passes through 0. So x equals 0 is going to be the the axis of symmetry for the vertical parabola. If it's horizontal, then a horizontal line divides it in half. Is that equation x equals or y equals? Y equals 0 divides that in half. In both situations, the vertex is located at what? 0, 0. So these are kind of the parent functions. We will shift these around, but that'll be at a later time. Focus. Got to know some information about that. The focus is p units on the inside. So I'll put F for focus, and it's exactly p units from the vertex. So what you need to know is how to find p, correct? We use this equation. A, or the number in front, the coefficient in front of x squared or y squared, is equal to 1 over 4p. Now, A for the day. If this point is p units away from the vertex, what's its coordinate? 0p. What would be the coordinate of the focus in the next one? P0. Yep. The directrix is a line that runs perpendicular to the axis of symmetry. It also sits p units away from the vertex. Horizontal line or vertical line? Horizontal. X equals or y equals? Y equals. What is the y value that it goes through? Not p, but negative p. Right? Next one. Directrix. Vertical or horizontal? Vertical. So x equals or y equals? And this one's x equals negative p. Yo. Same thing, yep. A equals 1 over 4p. Okie dokie. Direction of opening. Okay. If A is positive, then the parabola goes which direction? Up. If A is negative, then the parabola goes down. What do you think it is for the next set? Yes, A is positive, it goes to the right. If A is negative, it goes to the left. Length of the lattice rectum. Yes. Here is the segment. The length of the lattice rectum is the absolute value of 4p in both situations. And I'm going to draw for you the segment. It runs through the focus, and that shows how wide the parabola gets. So that segment, the lattice rectum, tells us how wide the parabola gets. Your book uses another term called the focal diameter. Focal diameter is the measure of the lattice rectum. I forget it. We just, if you see focal diameter, and then you just think lattice rectum. Okay, it's the length of the lattice rectum. And that's it. Wait, what happened there? Where's my recording? Oh, that's a different one. Oh, wait. Okay, so wraps up our lesson. Tomorrow, what I'm going to show you is this. I'm going to show you how to actually graph these parabolas with the appropriate characteristics so you can enjoy a night off right now.